Hi everyone, in this video we are going to discuss this example of Lorentz series. So we have this function f of z is equal to this one and we have to find its Lorentz expansion, Lorentz series for two different domains. So let us start with a given function. Let me mention here, we have, what is the function? We have f of z is equal to 1 upon z minus 1 square z minus 3. So our first task is to make those brackets separate. Getting? So we should make them separate, then we can easily find its Lorentz expansion. So let us see how to make them separate. Here I am going to use that partial fraction method to make them separate. So we know that in previous example we have seen, if you have two brackets, suppose we have x minus a, x minus b, then what we consider a upon x minus a plus b upon x minus b. If you have three brackets in denominator, x minus a, x minus b, x minus c, then we write a upon first bracket, b upon second bracket, plus c upon third bracket. But the problem is that here we have one bracket with square. So that technique is not applicable to make them separate. So there is one rule of partial fraction to express them. Okay. So that rule is, so I am going to consider, so this is equal to a upon z minus 1, that bracket I have considered, but see that bracket has square. So I should go further, b upon z minus 1 square. So the square is achieved, so that's why we will move to the next bracket. If we have cube here, then I should write c upon bracket cube. Fortunately, we have square only, so square is completed here. So let us go further, c upon the third bracket, z minus 3. There is no any square, so that's why simply we will write c upon bracket. So in this way, we have assumed this one. So let me mention here, assume. Okay, just a minute. So this thing we have assumed. So now what we have to do, we have to find the values of a, b, c. Then we will have separate brackets. So let us make that denominator same. Okay, so what will I do? There is one technique to do this. I will copy the same denominator here. What we have? Z minus 1 square, z minus 3. So let us talk about the first term. What we have? Z minus 1. Actually denominator is z minus 1 square, z minus 3. That means z minus 3 is missing here, as well as one bracket of z minus 1 is missing, since we have simply z minus 1. So let us multiply a by those two terms. That means z minus 1, z minus 3. So let us talk about b now. Okay, b into. In denominator of b we have bracket square. Let us put hand here. So z minus 1 bracket square is over. Getting? So what is remaining? Z minus 3 is remaining. So let me write here z minus 3 plus c. In denominator of c we have z minus 3. So let us put one hand here. So the remaining part is z minus 1 square. So let us multiply c by z minus 1 square. I hope all of you understood. That is, if you have a upon z minus 1, okay, one bracket was covered, so z minus 1 and z minus 3 was remaining, so simply I multiply a by z minus 1, z minus 3, and I repeated the same procedure for b and c. So in this way I got this one. So now the denominators are same. So we can cancel out and simply we can compare numerators. So let me mention here, therefore these two are equal, having same denominator, so that's why I am cancelling and I am comparing numerators. So 1 is equal to, what will you get? A up into z minus 1 z minus 3 plus b z minus 3 plus c z minus 1 square. So let us recall what is our target. Our target is to find values of a, b, c. After that, what we do, we put the value of z such that we will get maximum zeros. So easily we will get values of constants. Okay. So what do you think what we need to put? See, I am going to put z is equal to 1. So z is equal to 1 I put. So 1 minus 1, 0. Here we will get 0. Here also we will get 0, so we will easily get the value of b. So let us do that. Okay, we have some space, let us use. Putting z is equal to 1. Let us see what will happen. The left hand side is same, 1 is equal to z is equal to 1. I am putting 1 minus 1, 0, and 0 into anything, 0, plus. Let us talk about the second term. Here I am putting z is equal to 1, 1 minus 3, minus 2, plus here I am putting z is equal to 1, 1 minus 1, 0. So the third term will be 0. Get it? So b is equal to, if you solve, we will have b is equal to minus 1 by 2. So in this way I got the value of b. Let us move further. Okay, so let us put the second value now. We have to find the values of a and c now. So putting, so what do you think what we need to put? Let us think. So yes, now we will put z is equal to 3. If I put 3 here, 3 minus 3 is 0. We will have this one 0, this one 0, and we will easily get the value of c. Putting z is equal to 3 here, left hand side is constant, which is 1. If I put 3 here, 3 minus 3 is 0, and 0 into anything, 0, plus if I put 3 here, 3 minus 3, 0, and 0 into anything, 0, plus if I put 3 here, 3 minus 1, 2. So let me write here 2 square is also there. So 2 square is 4. So the value of c is 1 by 4. So in this way we got the value of c also. So let us go further. Now we have to find the value of a. Okay, a. Let us try to put something such that we will get maximum zeros. Putting z is equal to. What do you think what we need to put now? If I put 1, we will have 0, but it is already covered. If I put 3, we will have 0, but that case is also already we have discussed. And see, there are no any chances. So if I put anything, we will not get easily all zeros. So what will I do? I will simply put z is equal to 0. Left hand side is constant. 1 is equal to a. Here I am putting 0. Here also I am putting 0 at a place of z. So we will have minus 1, minus 3, plus here I am putting 0. So b we will have minus 3, plus here also I am putting 0. So c minus 1 square. So 1 is equal to, if you take product, we will have 3a. If you take product, minus 3b. If minus 1 square is 1, c. So 1 is equal to, but see, we have the values of b and c. So let us put those values here. So 3a, I am putting value of b, which is minus 1 by 2. So we will have 3 by 2, and value of c is 1 by 4, 1 by 4. So let us take all terms on one side. So 3a is equal to 1 minus 3 by 2 minus 1 by 4. So in calci also we can easily solve, or let us make the denominator same, 4. So 4 minus 6 minus 1. So it is minus 3 by 4. So a is equal to, see actually the 3a, let me write properly, 3a is equal to minus 3 by 4. 3 will get cancelled, and the value of a is minus 1 by 4. Let me highlight it. Okay, so in this way we got the values of a, b and c. So therefore we can write our f of z, a. What is value of a? Minus 1 by 4, minus 1 by 4 upon z minus 1. What is value of b? It is minus 1 by 2 plus minus 1 by 2 upon z minus 1 square. And what is value of c? It is 1 by 4, 1 by 4 z minus 3. So the first task is over, that we have expressed them separately. So now we can easily find their Lorentz series for given domains. Okay, so make a screenshot of it first, then I will go further. So I have written that series properly. F of z is equal to this one. So let us discuss those domains one by one, and we will find the Lorentz expansion of given function for those domains. Okay. So what we have here, let me write. The first domain is 0 less than mod z minus 1 less than 2. So before starting our discussion, let us recall one thing. Okay. So that thing is, in Lorentz expansion, mostly we use this series 1 upon 1 minus z, which is 1 plus z square plus z cube and so on, and this series is valid with that condition mod z must be less than 1. We have a second series also 1 upon 1 plus z having alternating minus plus signs, and again the series is valid for mod z less than 1. Okay, so mostly we use these two series to find Lorentz expansion of any function. Okay, so yeah, our focus is on that one. See, this is a given domain we have, so let us talk about its geometry first. Actually, it is not compulsory part, it is not necessary. Without knowing the geometry also we can find the Lorentz series, but let us talk about it and then we will go for the Lorentz series. See, what we have here, inequality we have, so we replace inequality by equality, so we will easily have the region. So I am replacing inequality by equality. So this is equation of circle with center 1. 1 means real part is 1 and imaginary part is 0, and its radius is 2. Actually, I am comparing this equation of circle with a standard equation, center z0 and radius r. So here let me draw a very small figure here. This is imaginary axis, real axis. So what is its center? Its center is 1, 0, somewhere here 1, 0, and its radius is 2. So radius is 2. So I am taking, okay, radius 2. So we will have a circle like this. Okay, but see, it is strictly less than 2. That means we have to consider simply interior part of a circle. It's less than 2, less than radius. So this is a region we have. This is a region. Okay. Okay, so this disk we have, and one more thing, it is strictly greater than 0. That means actually the center is removed. Getting? So that disk we have which center is removed from the disk. Okay, so such region we have, and for that region we have to find the Lorentz expansion of this function. Okay, we have already expressed it in this way. So let us go with a condition. So let me write, we have, what is the condition we have? Mod z minus 1 less than 2. But did you notice one thing? In the Lorentz expansion, always we need to have mod of something less than 1. In the right hand side we have 1. Here in the right hand side we have 2. So what will I do? I will divide both sides by 2. If I divide both sides by 2, z minus 1 by 2. If you divide it by 2, we will have 1. So that means we have a condition similar to that. Getting? So less than 1, here also we have less than 1. Doesn't matter what we have inside the mod, it is z minus 1 by 2 I have got. Okay, so let me write properly. Yes, this is the thing we have. So let us start with a function f of z is equal to what we have, minus 1 by 4 z minus 1 minus 1 by 2 z minus 1 square plus 1 by 4 z minus 3. You remember in last video I have already told you whatever inside mod we have got. Okay, so what we have got inside mod, it is z minus 1. So if you already have z minus 1, don't disturb that term. Here we have z minus 1, so I will not disturb this term. Here also we have z minus 1, I will not disturb this term. Here we don't have, so that means we need to manage z minus 1 there. Let us do. So minus 1 by 4 z minus 1 minus 1 by 2 z minus 1 square. So how to manage z minus 1? Will you tell me how to manage z minus 1? The technique is very simple. Z minus 1 minus 2. So I got z minus 1. Minus 1 minus 2 is minus 3 again. Without disturbing the term, actually without disturbing the meaning, I wrote express in a form of z minus 1. Okay. One more technique is there. I have already explained in the last video, that is whatever we have in denominator, that thing we need to take common. In denominator we have 2, so I should take 2 common here. So let me write minus 1 by 4 z minus 1 minus 1 by 2 z minus 1 square. Here I will take 2 common, so 2 into 4 we will have 8. Z minus 1 by 2, there is no any 2, so that's why I should write in denominator. Here if you take 2 common, 1 will be there, right? If you take product again with 2, you will have the same term. Okay, so I have written the same by simply taking 2 common. Let us move further. Okay, we have some space, let us use. So simply copy paste we have to do for first two terms, minus 1 upon 4 z minus 1 minus 1 upon 2 z minus 1 square. So now the question is, can we use those expansions for this one? And the answer is no, because here we have 1 first and here we have some term and a 1 second. So what will I do? I will take minus sign common, so we will have 1 first. Let us take minus sign common. So if I write minus, sign will get changed. This 1 will be positive and this term will be negative, minus z minus 1 by 2, right? So now again the question, just a minute, let me copy this one, minus 1 upon 4 z minus 1 minus 1 upon 2 z minus 1 square. So now the question in mind, can we expand, okay, this bracket with this standard series? Here we have 1 first, in both series we have 1 first, minus, yes, minus is there. The condition is mod of this term is less than 1. So can we say mod of this bracket is less than 1? Yes, mod of this bracket is less than 1. That means definitely we can use those expansion. So let us use the expansion. At a place of z, we have this bracket, okay, 1 plus, all sign plus, z minus 1 by 2 plus z minus 1 by 2 square plus z minus 1 by 2 cube plus and so on. So this is required Lorentz expansion for this domain. Okay, so make a screenshot of it. After that we will go for the second domain. Make a screenshot of it. So now let us discuss the second region. Okay, so this disk we have, let us draw it first. Let us talk about its geometry and then we will find its Lorentz expansion. Okay, mod z minus 3 less than 2. First of all, I will replace inequality by equality. Mod z minus 3 is equal to 2. So this is the center and this is its radius. So radius is 2 and the center is 3 comma 0. Real part is 3, imaginary part is 0. Let me draw a very small circle here. Okay, this is real axis, this one is imaginary axis. Okay, I'm drawing scaling here. Okay, so the center is 3 comma 0, it will be somewhere here and the radius is 2. So radius is 2. Okay, so such type of disk we have, getting? So dotted because strictly less than we have, and less than, that means interior part of a disk. So such disk we have here. So you can say this is the region of convergence. What we say, it's region of convergence. Strictly greater than 0, that means center of that disk is removed from it, getting? So such disk we have, and for over that disk or over that region of convergence we have to find Lorentz expansion of this function. Okay, so let me write here the condition. We have mod z minus 3 less than 2. So mostly we use these two series to find Lorentz expansion. Okay, but see, the condition is there, mod z less than 1, here also mod z less than 1. Z doesn't matter, the mod is less than 1. Here we have mod less than 2. Actually we want less than 1. So what will I do? I'm going to shift 2 on this side, or you can say divide both sides by 2. So we'll have mod z minus 3 by 2 less than 1. So similar to that condition we have got something, mod of something less than 1. Okay, that's okay then. So let us go with a function f of z is equal to, let me mention then, f of z, what we have, minus 1 upon 4 z minus 1 minus 1 upon 2 z minus 1 square plus 1 upon 4 z minus 3. So see, I have already told you, whatever inside mod, if you get it directly, don't disturb that term. So here inside mod we have z minus 3. Fortunately here we have z minus 3 directly, so I will not disturb last term. Here there is no z minus 3, here is also there is no z minus 3. That means we need to work on first two terms. Okay, so let us start. How to adjust z minus 3? It's very easy, no? Z minus 3 plus 2. Minus 3 plus 2, that means again minus 1. I will do the same thing here to adjust z minus 3. Z minus 3 plus 2, just bracket square is there, plus 1 upon 4 z minus 3. It is directly z minus 3 we have. I will not disturb it till the end of this solution. Okay. See what we need to do after that. See, I have already told you the technique. So that technique is whatever we have in denominator, we need to take that term common. So in denominator we have 2, so that's why I will take 2 common. Where we can take 2 common? From this bracket we can take 2 common. From this bracket also we can take 2 common. So let us do that. Minus 1 upon. So if you take 2 common, we will have 8 outside. 4 into 2, 8. If you take 2 common, z minus 3 by 2. Okay. If you take 2 common, we will have 1 minus. Here also I will take 2 common. Let us take 2 common. But see, bracket square is there. That means if you take 2 common, it will come outside with a square, which is 4. And 4 into 2, 8. So I am taking 2 common. So z minus 3 by 2. If you take 2 common here, we will have 1 square. Plus 1 upon 4 z minus 3. Okay, so let us move further. Okay. See, can we use those series here? No. And the reason is, here always we have 1 first. Here we have something other than 1. We have 1 second. So let us interchange them. Okay, so we can apply the series. So which is equal to minus 1 upon 8. I am taking 1 first. Addition is there, so simply you can interchange. 1 plus z minus 3 by 2. I will do the same for this one. So 1 upon 8. So 1 plus z minus 3 by 2 square plus 1 upon 4 z minus 3. Everywhere we have got z minus 3, z minus 3. So can we expand? Let us check. So minus 1 by 8 we have. Let us see, can we find expansion? 1 we have first. Yes, here we have 1 first. Plus is there, plus is there. At a place of z minus 3 by 2 we have. The condition is mod of this z less than 1. So mod of this term should be less than 1. Then only we can use that series. Mod of this term is less than 1 already we have. So definitely we can use this series. Simply at a place of z we have z minus 3 by 2. So let us do 1 minus z minus 3 by 2 plus z minus 3 by 2 square minus z minus 3 by 2 cube plus and so on. Okay, so let me remove this diagram. It is not required. See, let us talk about the second term now. See, minus 1 by 8 we have again getting. So let us talk about 1 we have 1, we have plus. See, there is no bracket square. We have a bracket square. That means definitely that series is not applicable. Then if you have square, then what we need to do? See, I am also confused how to find the expansion then. But see, there is one technique. So that technique is, what will I do? I will take derivative of both sides. Let us see what will happen. Derivative of this term is minus 1 by 1 plus z square. Agree? Derivative of this one. So let me write simply here. Minus 1 by 1 plus z square. Since derivative of 1 by z is minus 1 by z square, that formula I use. Derivative of 1 is 0. Forget it. Derivative of z is 1 plus derivative of z square is 2z. Derivative of z cube is 3z square and so on. We don't want minus 1, then let us multiply all sides by minus 1. So 1 upon 1 plus z square. If you multiply each term by minus 1, sign will get changed. 1 minus 2z plus 3z square and so on. Is it clear? So in this way, we derived, let me remove this one. So we have derived the series for 1 upon 1 plus z bracket square, since here also we have bracket square. So this expansion we can use and the same condition is valid. Okay. So let us go further. I'm going to use this expansion. So we have 1 minus. See, at a place of z we have z minus 3 by 2. Let us do. So minus 2 we have z minus 3 by 2 plus 3, that z minus 3 by 2 square and so on. So in this way I got the expansion of second term also. And last term is there. Okay, we need to simply copy paste 1 by 4 z minus 3. In this way we got Lorentz expansion for this function. Okay, this function for this domain also. So make a screenshot of it, then we will stop. Thank you. See you.